Hello students, welcome back to my channel. Let us continue learning database concepts. In today's sessions, we will be looking into four individual concepts. They are participation constraints, cardinality, generalization and specialization, also aggregation. So these are the individual topic, but yet they are connected to somehow to the previous topic which we have studied, that is your ER diagram. So let us see them one by one, right? So the very first one is participation constraint. So before getting on to the participation constraint directly, let us understand what is constraints in general means. So in real life, when we talk about constraint, it is nothing but certain limitations we are applying on something. Constraint is nothing but we are putting certain rules. Similarly, even in DBMS, when I say constraints, it is nothing but set of rules or conditions that are applied to the data, okay, within the database to ensure the data integrity, consistency and adherence to the business rules. So what is the meaning of that? So we know that database is nothing but a collection of data, and in relational database especially we are going to store them in the form of tables and that is rows as well as columns. So whenever I'm storing the data, we know that in a database I'm going to have a n number of tables and they are all going to be connected to each other. In such situation, if I'm not having any rules about the data which I'm storing, then it is going to be very difficult to maintain the integrity of the data. That is the reason we need to have certain constraints about the data we are storing in the database. So these constraints define limitations and requirements that the data must meet. So if I want to store a data, it has to follow these rules. For example, for a particular date of birth, if I'm saying that it is an employee database and date of birth, where whatever I'm entering, the employee should be greater than 18 years old. So that is a constraint which I am putting, saying that there cannot be an employee who is less than 18-year old. So that becomes a constraint. So whenever I'm entering a database, suppose I'm entering a date of birth as 1st July 2020. So that means it will give me an error saying that person is not yet 18 years old. So this is how we put certain constraints in a database while entering the data, and all the data whatever we are entering should adhere to the particular rule whichever is applied, right? So now see what is the participation constraint means. So we know now what is a constraint. So what is a participation constraint? So when it comes to the participation constraint, there are two types. Okay. Now this is the diagram which we have already seen. So we have a relation here. We have an entity. So we have seen the definition and everything in the previous sessions. So kindly go through those videos to understand. So we have two entities participating in a relationship here. As you can see, there are two types of participation constraint. One is total participation, another is partial participation. Now what is this? Also you can see that total participation is being drawn with the help of a double line, wherein which partial participation indicates a single line. Now this is how we represent in an ER diagram. Whenever you see a double line, you should understand that it is a total participation and a single line indicates a partial participation. What is the difference? A total participation, each entity in the entity is involved in a relationship. So here all entity should be participating in the relationship. There is no a way that a single entity or a single is not participating in a relationship. That cannot happen. For example, if I'm saying that I have a student entity where I have students S1, S2, S3. Okay, there are three students, for example, and I have a course. Okay, there is course 1, course 2. There are two courses in the college. So the relationship is participation, or students takes a course. So takes is a relationship. So which means if you are a student, that is you must and should be enrolling in some course, isn't it? So student has to have a total participation. There cannot be a student saying that I am a student of this college, but I'm not taken any course. That is not possible. But is it possible that there is a course, but no students are enrolled for that? That is possible, isn't it? That is why we will call this as a partial participation. So this becomes our total participation and this becomes our partial participation. Okay, so see here, participation to partial participation, not all the entities are involved in the relationship. Partial participation represented by single line. So if you understand this example, you will understand the meaning of this total participation as well as partial participation. Now, what is the role of constraint here? So when I say participation constraint, if at all I am saying that this particular entity should have a total participation, which means all the entities should have a participation in the relationship. That is a constraint. The moment you are saying that no student is taking a course, there has to be an error. Similarly, in the partial participation, there can be a possibility that no student has enrolled for the course. That is allowed when it comes to the partial participation. This is your partial constraint. I hope this is clear. Now next let us move on to cardinality. Along with that, we will also be learning what is ordinality. Now what is this cardinality? So we know now that we know what is a participation. Cardinality specifies how many instances of an entity are related to one instance of another entity. So, which means that once again, if I'm having two entities, when there is a relationship, the cardinality tells me that how many instances of one relationship is participating in the relationship with the other entity. That is what a cardinality. This number, whatever the number we will give here, is nothing but the cardinality. What is ordinality then? Ordinality is also closely linked to cardinality. While cardinality specifies the occurrences of the relationship, ordinality describes the relationship as either mandatory or optional. That's all ordinality is going to tell us. It will tell us whether it is a mandatory relationship, that whether all the entities should participate, or is it optional. Okay, so in other words, cardinality specifies the maximum number of relationship. So if I say n, which it can be 1 or 1 to n. Okay, but if I say ordinality is 1, which means only one can participate, and ordinality specifies the absolute minimum number of relationships. So as you can see here, this is some indication we have seen here, n and 1, which means account 1, n number of customers can have one account. Similarly, one account can have n number of customers. Also, one account can have m number of transactions, and m number of transaction can happen in one account. So this number indicates your cardinality as well as ordinality. Now you can also see here certain symbols, something like this is called as a crow leg, now crow feet. Now we are going to let us now go ahead and see what this different symbol means. Now this cardinality and ordinality, what we have seen, can be represented in various formats. Okay, now there are different kind of representation has been given by different peoples. Now we are going to be seeing them one by one. Now before that, so see here, I have a teacher and I have a class. Now there is a participation happening here. So here this double line, and this means this is 0 or n, this means this is mandatory. Okay, so cardinality as well as this becomes cardinality, which is that when there are double line, which means this will represent your ordinality, this is your cardinality. Similarly, 0 or n, which means the first one represents cardinality, this is that minimum is 0, and this is n, this represents your ordinality. Okay, that we will see in detail now. So here what is happening, teacher is participating in a relationship, so one teacher has to be assigned to class. Okay, the minimum as well as maximum is one teacher has to be there for a class. um, uh, so for a class there has to be some teacher, but a teacher might have 0 or n. He might be having no classes at all. Also, he might have more than one classes. Okay, n number of classes are also possible for a teacher. So that is represented something like this. So let us see those different notations, different kinds of representation for ordinality as well as cardinality. The very first method is information engineering style. So this is a style which is called as a information engineering style. Remember, these are the cardinality notations which we can use when it comes to the ER diagram. The examples are also given in the side, so just have a look at it. So when I say a single line, it is nothing but one-to-one relationship. When I say a line like this and a crow feet like this, which means that here it is one participation, one entity should be many. This is nothing but many. So as you can see here, one company can have many employees. Okay, so this represents many. So one company can have one or many employees, and one or many employees may be working in a one company. They cannot be working in more than one company, isn't it? So one or n employees will be working for a single company. So the relationship from here is one or n employees working for a single company, but one company can have one or n employees. That is what the meaning is. If you see simply like this, a single line like this, which means this is many. If you say line and crow feet, it is one or more, just like I told you here. Crow feet as well as single line is one or n. And when you say double line, it is one and only one. It is just a mandatorily it has to be only one. If you say a bubble and line like this, which means 0 or 1, and if you say a bubble and a crow feet like this, it means it is 0 or many. So here you can see employee. So one or n employee will be working in a project. Okay, so one or n employee will be working in 0 or n project. There is a possibility that an employee doesn't have a project, or he might be working in more than one project. That is possible. But a project will have mandatorily one or n employee, or at least one employee will be working in a project. So that is what this indication means. So this is your information engineering style indication or notation for cardinality. Now let us see the next one. This is Chen style notation for cardinality. So here what is happening is, here we mention in the form of m is to n. So when I mention like this, it means what is a participation. Okay, so here the first number indicates cardinality, that describes the minimum, that is the optional number of participation. Cardinality describes the maximum. So when I say 1 is to n, which means 1 to 0 or more. Okay, so when I say 1, there has to be a minimum 1 participation. N, when I say, it can be 0 to n number. So similarly here you say one company should have 0 to n employees, and 0 to n employees should be working for one company. Similarly, m is to n nothing but m and n will have the value of 0 to infinite. Okay, so here we have m or n employee, that is 0 employee might be working for a project. There might not be any employee assigned, and similarly employee might not be assigned any project. That is possible. Similarly, in a project there may be n number of employees working, and n number of employees working in a project, and an employee might be working for an n number of projects. That is, an employee might be having 2 to 3 projects he is working on. Similarly, a project might be having more than 10 people working on a single project. That is also possible. That is why we say that the relationship between employee and project is m is to n. Similarly, 1 is to 1 means there is a single relationship, that is one um, person or one entity is participating in mandatorily one relationship. That is called as a one-to-one relationship. For example, one wife will have one husband. Similarly, one husband should have a one wife. That is nothing but your one-to-one mandatorily single relationship is called as one-to-one. So this is the Chen style, where we will mention the n1, n and m and everything to represent the cardinality and ordinality of a relationship. Right? Now let us see the next style. This is called as Bechman style. So here what we are, as you can see, is what we are doing is we will have a line with all those dots. So when I say it is a filled dot, it means 1. Okay, filled dot is nothing but 1. So both the side I'm having filled dot, which means it is 1 to 1. If I'm having a hollow dot, which means it is 0 or more to 1 or more. So when I say here this is arrow, means it is 1 or more. Again here it is a filled dot, which means 1, 2. So when I have this arrow, which means that 1 or more. So same thing here, company, I'm having here 1 and it is 1 or more, which is nothing but our n. Okay, arrow means 1 or more. Similarly here 1 or more to 0 or more. Here it should be 0 or more. Okay, this is a very simple notation, but usually we will not be using, we'll be using either engineering style, or we have seen Chen style mostly, because we will be writing those m is to n. Very often you will see that representation used in many of the ER diagrams. Next one is your Martin style. So in Martin style, we again indicate ones and zeros and stars. So what is the meaning of this one? Now one here simply means one and only one, mandatorily. Star means many. So you can see here, one company can have many employee. Many employee will be working in one company. Okay. So if you have this 0 dot dot 1, it is nothing but 0 or 1. 0 comma 1 mandatorily means 0 or 1. It can be any one. 1 comma n means 1 or more, and 0 comma n means 0 or more, and 1 comma 1 means 1 and 1 only. So this type of a style also we will see in certain ER diagrams, so you should know what is the meaning of that. So similarly here you see employee. So when I say 1n, it is 1 or more employee might be working in a project. Similarly 0 or more employee might be having a project. So this is the relationship between this is how the ER diagrams, relationship between the entities are represented in the ER diagram using the Martin style. Now that we have seen the different notations to represent the ER diagram, that is your Martin style, Bechman style, Chen style, and information engineering style, let us go ahead and see the new topic, that is your generalization and specialization. Okay, so what is this generalization and specialization? So when we are representing in an ER diagram, we know that we represent with entities. Now suppose if two entities, I'm clubbing it together and it gives me a meaning of forms a new entity, then I will call it as a generalization. Similarly, when I say specialization, I have a general entity. If I'm able to divide into sub-entities, then I will call it as a specialization. Okay, so generalization is a bottom-up approach. That is, I will from specific, I will go to general. Okay, that is generalization. So that is why it is a bottom-up approach in which two lower level entities combine to form a higher level entities. In generalization, higher level entities can also be further combined to form a higher level entity. So as you can see here, I have savings account, current account. Together I can represent it as a single account. That is a single higher level entity, which is account, which is nothing but there are two types, savings account and current account. So bottom up approaches, I'm clubbing this savings account and current account and forming a single entity, that is your generalization. So opposite of this is called as a specialization. So this is a top down approach. Okay, so specialization is opposite to the generalization. It is a top down approach in which one higher level entity can be broken down into lower level entities. So if I'm giving the same example, an account can be divided into current account, savings account, business accounts, etc. Similarly, a student can be subdivided into current students and ex-students, that is the passed out students. Okay, so in specialization, some higher level entities may not have a lower level entity sets at all. Okay, so it's not necessary that we should be able to divide or specialize every entity. It is not mandatory, but there may be situation where we'll not be able to further divide any entity. That is also possible. Okay, this is our generalization and specialization. I hope this topic is clear. Now next, let us move on to the last topic of the day, that is aggregation. So what is aggregation when it comes to the ER diagram? So aggregation is a process when the relation between two entities is treated as a single entity, which means I'm having two entities here, but as a whole I'm treating in the ER diagram them together as a one. That is why it is called as aggregation. You even usually in mathematics we have learned about aggregations. So the same method applies here. We are aggregating the two entities, right? So here relation between the center and course is acting as a single entity in a relationship with the visitor. So visitor inquires about the organization. So in an organization I have a center which offers course. But when visitor is inquiring, we are together combining them as a one, thinking that the visitor is inquiring about that particular organization. So doesn't matter whether the center is offering the courses or course is offered by a center. Basically, a visitor is inquiring about the center or about the organization itself. So here, these two entities have been combined together, or in other words, aggregated together and have been used. Okay, so as you can see, it is drawn in a way that it shows that aggregation. Okay, so these are the different representations which we use in the ER diagram. So this should be clear for us, so that when we see any ER diagram, we should be able to read it. So any diagram is given, whether it is cardinality, whether it is aggregation, whether it is generalization and specialization, different kinds of attribute. The main reason of learning all this is we should be able to understand or get the meaning out of that ER diagram, because as we have learned, ER diagram is nothing but the representation of a database. How the data is related to each other in a database is represented in the form of ER diagram. So if we are able to read the ER diagram, then we can understand the relationship between the data inside the database. That is the ultimate purpose of learning all these concepts. I hope these topics are you are able to understand, and it is helping in your study, students. Do let me know which is the next topic you want me to take up. Till then, keep learning. Thank you for watching.